So number 7, for the ratio sec theta equals -4/3, the angle theta is in standard position, so which means that the angle is between 0 degrees to 360 degrees. And so for part A, it says find all 5 other trig ratios for theta. So first thing what I'm going to do is I'm going to break down that sec theta so that the negative is at a specific numerator or in the denominator position. So recall that the 4 will be the radius and 3 will be the x, since sec theta is equal to, or secant theta is equal to 1 over cos theta. So based on that, because radius can't be negative, I'm going to write x as a negative. I'm going to actually put the negative in the denominator. Radius can't be negative.
Okay, so for step 1, I need to figure out some other part. So basically I have my radius and I have my x value, but what I don't have is I don't have my y value. And so I have x squared plus y squared equals r squared. X is -3. I don't know my y. My radius is equal to 4. So -3 squared is equal to 9. And then I have 16 for my 4 squared. I want to get my y by itself, so I'm going to do BEDMAS backwards to do that. 16 minus 9 is equal to 7. To get y by itself, I'm going to square root both sides. There's a plus and minus version. And keep in mind that for my x or y value, it is totally fine to get a plus or minus version, whereas for the radius, only the positive value would be grabbed. So that was my step 1. Let's move on to step 2 to actually find the other trig ratios. So at first, what I'm going to do is write down all my formulas for my 5 trig ratios. So I have sine theta is equal to opposite over hypotenuse. And based on the summary, which is over here, sine theta is equal to y over r. Cos theta is equal to x over r. Tan theta is equal to y over x. For my cosecant theta, it is the reciprocal of sine theta, so it's simply r over y. For my cotangent, it is the reciprocal of tan theta, so it's x over y. So all of these are my primary trig ratios, and the other ones over here are the other secondary. At this point, I'm just plugging in all my values. So my y value is equal to plus minus square root of 7. My radius value is equal to 4 from above over there. My cos theta is equal to -3 for x, and radius is 4. Tan theta is equal to plus minus square root of 7 divided by -3, which simplifies to plus minus square root of 7 all over 3. If you have that negative there, well, you have a plus and minus version of it anyway, so that's going to overpower it. For r divided by y, r is equal to 4. R is equal to plus minus square root over 7. And then x over y is -3 over plus minus square root of 7. The ones on the bottom, I have a radical on the denominator, so I need to rationalize by multiplying by the square root of 7, and I get 4 square root 7 over 7, and I can just drag the plus minus sign to the numerator. And same idea for the bottom. I am going to multiply the top and bottom by square root of 7. So I'm going to get -3 square root 7 divided by plus minus square root 7, which is basically writing plus minus 3 square root 7 over 7. So that's your answer for part A. Possible measures of theta in the given domain. So what I can basically do is grab any of the trig ratios and try to grab my theta from that. It looks like cos theta is like the most simplest looking one. For my secondary prime ratio, For my secondary trig ratio, keep in mind that this is not on the calculator, so I'm going to use my primary trig ratio. So the one I'm going to write is about the cos theta, and this is my first rough work. So what I'm doing is I need to find the related acute angle using one of the above trig ratios, and I have to keep in mind to drop any negatives within my calculation initially so that I refrain from getting any obtuse angles. So this is just one way that we can do this. And so by doing that, I am getting my related acute angle. Remember, this R stands for related acute angle. So I'm going to do cos inverse of -3/4, but instead of -3/4, I'm going to drop that negative and just write 3/4. And so I have for my related acute angle an angle of approximately 41 degrees. As an FYI, related acute angle, there are two things that are true about it. One is that it's always positive, and then the other is that it always is near the x-axis and it is with respect to the x-axis and not the y-axis. So I wrote step 1 and 2 because what I'm really doing is combining these two steps, because all you'll see is probably the rough work when you're working this out and then this final step when you're actually writing your answer down. So I'm going to start by drawing my x and y axis, and I have an angle of 41 degrees. So this is how I'm going to think about it. So I have my cast, C-A-S-T, and so what this is telling me is that I have a 41 degrees as my related acute angle, but the trig ratio inside was a negative. That means I will not have the angle stand here in these quadrants in quadrant 1 or 4, but instead I'm going to have the angles lie in quadrant 2 and 3. And how do I draw my related acute angle? It's always to the x-axis, and therefore I'm going to write 41 degrees inside here. And at that point, once this is drawn, I can draw my principal angle. And so my theta 1 is equal to, well, from here to here is 0. This is 0, this is 90 degrees, 180 degrees. So what I'm doing is 180 minus 41 because this straight line is 180 degrees. I need to remove 41 degrees. Therefore, this part is going to be equal to 139 degrees. And while for this terminal arm, I'm going to start from my initial arm. From here to here is 180, not quite at 270. And so easiest way to do is 180 plus 41. 180 plus 41 is equal to 221 degrees. So I'm just going to tell you that you're going to consider the negative when you're actually drawing out the angles, meaning that my cos theta was equal to -3/4, right? And so when I drew my terminal arms, I didn't draw it over here because this is where my cosine and all my trig ratios are positive, but I want it at the negative spot, and so that's why I'm drawing my terminal arms here. 0 of rough work, you are finding the related acute angle by considering the primary trig ratio and finding your related acute angle, which is always positive. And it's two respective to the x-axis. And as a next step, that you're drawing your x and y-axis, drawing your terminal arm based on cast and following on whether the trig ratio was a negative or positive, and considering that fact, and then finding your angles accordingly. And therefore, theta 1 is equal to 139 degrees and 221 degrees. So for question 8, for the point P, 5 comma -7, find cosecant theta. So by definition, cosecant theta is equal to 1 over sine theta. And because sine theta is equal to y over radius, that means 1 over sine theta is equal to r over y. 5 is my x, my -7 is the y. At this point, I have my y, but I do not have my radius. Therefore, my step one is to find the missing variable. So I'm going to find r, and I'm going to use the Pythagorean theorem to do that. Pythagorean theorem is a squared plus b squared equals c squared, but the version that I'm going to work with is x squared plus y squared equals r squared, based on how we drew the triangle from before, which is right here, which is on page 5. So plugging in, I have x as 5, my y is -7, and like so, 5 squared is equal to 25, -7 bracket squared is 49 equals r squared. As you notice, you are adding the squares of two numbers. That means you're going to get a positive radius every time, and it only makes sense that the radius, which is a dimensional idea, which is a dimension, is going to be always a positive number. So 74 is equal to r squared. I'm going to square root both sides, and I'm going to grab just the positive version because it's dealing with the radius. And so r is equal to square root of 74, and the units for that is just units if the units are not mentioned for radius. So for my step 2, I need to figure out my cosecant theta and what that is equal to. And because cosecant theta is the reciprocal of sine theta, it is 1 over sine theta, and therefore that's equal to r over y, because sine theta is equal to y over r. And I'm going to plug in what I know. My radius is equal to square root of 74, and my y is equal to -7. Just going to fix that up because it's bad format right now. And so cosecant theta is equal to, I'm going to bring that negative to the numerator. So it's -74 over 7. There's no need to rationalize because I only need to rationalize when the rational part is in the denominator. And so cosecant theta is equal to negative square root of 74 divided by 7. So it says for that same question, find the angle theta. So I said from the previous question, question 7, generally work with your primary trig ratios when you're looking to find the theta, because you only have the primary trig ratios in terms of on your calculator. And so if I write cosecant theta is equal to negative square root of 74 divided by 7 from what we just got from before, if I take it and so interpret it so that it's in terms of sine theta, well, I'm just going to take the reciprocal of the above. And so I have 7 over square root 74, and I'm just going to keep that negative sign because by taking the reciprocal, that doesn't change a sign, right? If you have a -2, the reciprocal of that is -1 over 2. The sign still carries on. Don't get confused with negative reciprocal. We're just taking the reciprocal, which just means flip the numerator and denominator. At this point, now it looks a little more approachable, and I need to get theta by itself. And so I'm going to sine inverse both sides so that I can get rid of the signs on the left side and I can get theta by itself. When you put that in your calculator directly as is, and not really ignoring the negative, I get -54 degrees, which suggests that it is in quadrant 4 by the fact that it's an acute angle. So let me show you what that looks like. So basically when I draw my x and y axis, that means my terminal arm is going to be about there. I've moved from the initial arm clockwise to get to -54 degrees. That means my principal angle is going to be what? It's going to be, because this is 0, this is 90, this is 180, this is 270. Easiest way of figuring this principal angle out is doing, well, this full circle is 360, so I'm going to do 360 minus 54, or -54 plus 360. And so at this point, I'm going to try to find my actual answer. And so I have -54 degrees plus 360 degrees. And so therefore, my angle that I get as my final answer is 306 degrees. So for number 9 and 10, let's try to summarize what we found so far. So for number 9, when trig ratios are 0 and sine slash cosine are plus or minus 1, then you're going to draw the circle. You're going to draw the circle and use the coordinates that are on the x or y axis. So you're going to match the definition, so x over y or r over x, whatever you're working with points to find the quadrilateral angle. And what this meant was that it's the angles that lie on the x or y axis. Think about this for a second. So for sine and cosine, recall that sine is representative of our y and cosine is representative of our x, given that we're working with a unit circle and the radius is equal to 1. And so that's why we're working with the quadrilateral angle. But this is a different story for tan. Well, for tan, what did tan mean? Tan wasn't the x, tan wasn't the y. Tan was representative of the slope. Well, when will tan be positive 1 or negative 1? Meaning, when will tan have a positive 1 or negative 1 as a slope? Well, at what angles? Well, for tan, if you're dealing with slope, if you have a slope of like this, that's certainly not going to get you a value of 1 for tan. That's going to be a 0. If you have a tan this way, well, that's a vertical line, and you're going to get a tan undefined for that. When you're going to get tan 1 is this. When it has a positive 1 as a slope, that is when tan is equal to 1. And what angle is that? Well, that angle is 45 degrees. For negative 1, it's going to be over here, and it'll have a related acute angle of 45 degrees. And therefore, I'm going to write tan theta is equal to plus or minus 1. It's not quadrilateral because it's not lying on the x or y axis, but the theta of the related acute angle is 45 degrees because this is when slope is 1 and slope is negative 1. And I hope you see what I'm talking about. Number 10. So if trig ratios are something else, okay, so what you're gonna do is, it was all nice and dandy when, it was these kind of examples. So what if your trig ratios are something else and it's not these numbers? What you're gonna do is you're gonna isolate the trig ratio. And then you're gonna do rough work for the theta r. So you're gonna try to find the related acute angle and you're gonna drop any negatives. And the reason you do that is partially because you want to try to get a related acute angle. But if you, let's say, take cos inverse of negative 0.5, you'll get 120 degrees and a obtuse angle. And to avoid that from occurring, that's why we're dropping any negatives. So we're working with a related acute angle every time. So number 3, it says draw where angles can be and place theta r, the related acute angle, beside the x-axis, and then use symmetry to find out theta 1, theta 2. So let's figure out some of these questions. 11, solve for angle if the angle is between 0 degrees to 360 degrees. So this is the letter beta, and I'm solving for beta, and basically I have to do BEDMAS backwards still, because I'm really solving for a variable, right? And so first step is I want to do BEDMAS backwards. There's no addition or subtraction to get rid of, but right now tan is being multiplied by -5, so I need to divide by -5 on both sides. Then tan beta is equal to -2 over 5. At this point, I want to get beta by itself, and how do I do that? Well, I have to take the tan inverse of both sides, which will get me my beta, and my beta is equal to, and I'm just going to write beta of related acute angle. And so I'm really solving for my beta related acute angle by doing this. And so I will get approximately 22 degrees, indicating that this is my rough work and it's not my actual beta. So as a next step, I'm going to draw my x and y axis so I can figure out where my angle actually is. So my related acute of 22 degrees. So how is that going to help me? I'm going to write cast, and right now I'm dealing with tan. And my tan of my original, which is the one right here, is a negative value. Well, this is where my tan is positive, but according to this negative part, that means I need to draw my terminal arm so that it is not in those blue quadrants, but it is here instead. And after that, I have to be super careful that I draw my related acute angle so that it's with respect to the x-axis. Once I have my drawing right, I have to state my beta. So for my first beta 1 is going to be 180 minus 22 degrees, which is equal to 158 degrees. For my beta 2, it's a full circle is 360 degrees, and 360 minus 22 degrees is equal to 338 degrees. So those are my final answers. So bend mass backwards again for question B. I'm going to have to do bend mass backwards, so I'm going to add 3 to both sides. That gets me -4 sine theta is equal to 3. I want to get sine theta by itself, so I'm going to divide both sides by -4. So sine theta is equal to -3/4. So this part is my rough work that I'm about to do. I'm going to find my related acute angle by taking the sine inverse of just the angle inside. And so this is equal to 49 degrees. So at this point, I'm going to draw my x and y axis. I habitually draw cast. I need to figure out where my angles are. So according to this, and according to my original, I have a negative trig ratio again. And so instead of having my sine line around here, I have to draw my terminal arm so that it is on the other two quadrants. And when I draw my related acute angles out, it's going to be right here. And so my respectable terminal arm is going to be, so my respectable principal angle is going to be this. So my theta 1 is equal to 180 plus 49 degrees, which is equal to 229 degrees. And my theta 2 is equal to, well, my initial arm to the terminal arm, so 360 minus 49 degrees, which is equal to 311 degrees. So for question C, I have sine beta is equal to 0.5, and so 0.5 can be rewritten as is equal to 1/2. So that means that is my y, that is my r. And there's a couple way to do this, and if we do the related acute way, so this is my rough work. Beta, the related acute angle, is going to be sine inverse of 0.5, which is equal to 30 degrees on my calculator, and that is an exact amount, so that's why I'm not putting the little dot, and this is my rough work. This is only my related acute angle and not my actual, and so that's why I have beta r. So to my x and y axis, I'm going to draw cast. And I use my highlighter so I can try to show you that this is the part where it's positive. And I'm noticing that it's a positive for my trig ratio, so I can go ahead and draw my terminal arms over here. My related acute angle was told to be 30 degrees and 30 degrees. And so my first angle is going to be beta 1 is equal to 30 degrees. And my beta 2, which is from the initial arm to the terminal arm, it's not quite at 180, but it's past 90, which means I'm going to do 180 minus 30. And so my beta 2 is equal to 150 degrees. Moving on to D, I have 2 cos t. Moving on to G, I have 2 cos t plus 1 equals 0. So basically, I don't have my cos t by itself. So I need to first do BEDMAS backwards, and I get 2 cos t is equal to -1. I need to divide by 2 on both sides, and so cos t is equal to -1/2. So when I'm finding my related acute angle as my rough work, I find that cos inverse of just 1/2 is equal to 60 degrees. So let's figure out where the terminal arms are going to be. So according to my cast, my cos is positive over here. And so when determining where my terminal arm goes, I'm noticing that my original angle is, my original trig ratio. So we gotta distinguish. This part is the trig ratio and this is the angle. So my trig ratio is negative. That means I'm going to draw my terminal arm so it's here and here because this is where my trig ratios will be negative for cosine. My first principal angle is going to equal to, and before I figure that out, let me put my acute angle so it's a lot easier to find my principal angles. And so my T1 is equal to, well, not 60 degrees, but 180 minus 60 degrees, which is equal to 120. And then T2 is equal to 180 plus 60, which is equal to 240 degrees. For h of tan theta is equal to 0, this automatically has a denominator of actually plus or minus 1 because it could be any number, right? 0 divided by any number still equals 0. So breaking that down, remember tan theta is equal to y over x. So that's my y, that's my x. I'm going to do my rough work where I try to find my related acute angle. And so I'm doing tan inverse of 0, and that is equal to 0 degrees. So that's not really accurate enough, and so let's try to break down my 0 and plus minus 1 and see what that looks like on the graph. I have my x and y axis and the unit circle, and I'm going to plot these. And the ones I need to worry about is the fact that where is my y value 0? Well, my y value is 0 only here. And so I'm going to write this is 1 comma 0, and that's -1 comma 0. And if I recall, that's where it's 0 degrees and 360 degrees, and this is where it's 180 degrees. So based on my drawing, the calculator told me it was 0 degrees as my only answer, but if you look at the full picture, you realize that you have 3 answers within this domain. And so you have theta 1 is equal to 0 degrees, theta 2 is equal to 360 degrees, theta 2 is equal to 180 degrees, and theta 3 is equal to 360 degrees. Question I. So if you're doing cos alpha equals 0, I'm going to break that down again. So you can say that it has like a denominator of 1. That way you can compare it to like a unit circle. And so then the 0 is the x and this is the r. And let's draw our x and y axis with the circle. The only spots where x has a value of 0 is over here. The only spots where the x can be 0 is over here. That's where x is 0. So the coordinates for that is 0, 1 and 0, -1. Well, what are the angles that make this true? Well, your first one is going to be alpha 1, which is equal to 90 degrees, and another one that's alpha 2, and that's equal to 270 degrees. Question D. Sometimes we use these Greek letters as our new x or theta and whatnot, and this one is called omega. And so in order to find omega, I need to take and consider tan W because I don't have the secondary trig ratios on my calculator. And if it's tan omega, well, tan omega is the reciprocal of omega. And so I have 1 over 5.64. And another version of that is negative 1 over negative 5.64 because that is also true because a negative divided by a negative is a positive. And so this is a y, this is an x. So my rough work involved is that for my omega of my related acute angle, I have tan inverse of 1 over 5.64, and I get that this related acute angle is equal to 10 degrees approximately. I need to keep going and draw my x and y axis. Tan is positive. My original had that my x value and my y value is positive, or my x value or my y value is negative. But overall, my tan is a positive, and so that suggests a positive slope. And so that means I need to draw it so that my terminal arms are here and here, where my related acute angle is 10 degrees. Here. So when I figure out my angle, my omega 1 is equal to 10 degrees, and my omega 2 is equal to 180 plus 10, which is equal to 190 degrees. Just gonna write that like to interpret the whole thing, that tan W or tan omega is a positive slope. Question E, I'm trying to solve for lambda. And so again, I have a secondary trig ratio, so I'm going to switch that up. Secant of lambda, that's the reciprocal of cos lambda. And so I'm going to write cos lambda is equal to, well, originally this had a denominator of 1, so I'm just so that it's easier to picture. That means this is going to be 1 over negative 1. And cos lambda is x over r, and so I need to actually switch the order of the negatives so that it's negative 1 over 1 to ensure that my radius is in fact a positive number. Involved. So my lambda related acute angle, I'm going to do cos inverse of negative, sorry, just the positive ones, because I usually take the positive version of it when I'm finding my related acute angle, just to make sure that it's an acute angle and not an obtuse. And I find that it is equal to 0 degrees. Again, that is not as accurate. Info, I don't know what that means and how to interpret it, right? And so if I draw my x and y axis with my circle of, well, where is x negative 1? And it has to be here, and that forces the y to be 0. And when you interpret the angle itself, you get lambda is equal to 180 degrees. Keep in mind that FYI, if you did do lambda of the related acute angle, if you did cos inverse of negative 1 directly, you would have actually gotten 180 degrees. So, but keep in mind that in this case, you don't have a related acute angle now, but you actually found the angle itself, and so then that is just the lambda itself. But I do like to use the picture every time, just so that I can be kind of consistent with my steps, what's going on, but I still want to show you the FYI part. F, cosecant theta, so I'm going to switch that up. Well, that has a denominator of 1. Cosecant theta has a relationship with sine, sorry, that's not theta, that letter is psi, like PSI, psi. When I take the reciprocal of that, I get 1 over negative 4, which could be negative 1 over 4. And let's interpret what that means. Well, for sine, I have my y for the numerator and my 4 for the radius. And the second one makes more sense. So as part of my rough work, I'm going to find the psi related acute angle. So sine inverse of just the positive 1, which is 1 over 4. And I get that the related acute angle is 14 degrees. X and Y axis. And when drawing my terminal arms, again, I always need my cast. Trig ratios and sine are positive. When I look at my original has a negative value. And so when I'm drawing my terminal arms, I'm going to draw it on the other part so that it is a negative in fact. My related acute angle is 14 degrees. So this is 14 degrees. And this is 14 degrees. And therefore, my first one is equal to 180 plus 14, which is equal to 194 degrees. And my second psi angle is equal to 360 minus 14 degrees, which is equal to 346 degrees.